Today we're going to be able to use the properties of logs to simplify and expand logs. So here are some of the properties of logs, and they're derived from the laws of exponents. So if a and b are positive real numbers, then if you have log base p of ab, so a, b are being multiplied together, that's equivalent to the log base p of a plus the log base p of b. So when you're multiplying, addition, they go hand in hand, just like they do with exponentials. Log base p of a over b becomes log base p of a minus log base p of b. So division and subtraction go hand in hand. Log base p of a to the c becomes c log base p of a for every real number c. So any exponent that you have goes down in front. The same laws apply for natural logarithms, which are ln. We'll talk about those a little bit later on. But if you see an ln, it works the same way as a log. All of the properties are going to be the same. Something that you need to be careful of is that if you have the log base a of x plus y, it's not the same thing as log base a of x plus log base a of y. Same thing goes for subtraction. If you have log base a of x minus y, it is not the same thing as log base a of x minus log base a of y. So just be careful of that. There's a lot of mistakes that come around with that. If you have something that looks like addition, you can't break that into anything. So let's look at some examples of evaluating. So log base 6 of 12 plus log base 6 of 3. So because we're adding these two logs together, we're really going to be multiplying. So I'm going to rewrite this as log base 6 of 12 times 3. Okay, so this is log base 6 of 36. And now I'm trying to figure out what this is going to evaluate to. So like we did last class, we can set this equal to x. And then rewrite this and say 6 to the x equals 36. So in this case, x has to be 2, so this evaluates to 2. So log base 6 of 12 plus log base 6 of 3 is 2. Same thing goes for subtraction. So in subtraction, that goes hand in hand with division. So we have log base 2 of 96 minus log base 2 of 3. So we're going to rewrite this as log base 2 of 96 over 3. And then we can divide 96 and 3 and get log base 2 of 32. And then we can set it up as equals x. So 2 to the x equals 32. So this is just going to be 5. So log base 2 of 96 minus log base 2 of 3 is 5. A few more properties that we need to know. Log base a of 1 is equal to 0, since a to the 0 equals 1. So an example would be log base 8 of 1 equals 0. Another property that we need to know is that log base a of a is equal to 1. So if the base and the number are the same, it's just going to be equal to 1, since a to the first power is equal to a. So an example would be log base 5 of 5 equals 1. Log base a of a to the x is equal to x. So again, if the base number and the number that the exponent is attached to are the same, it's just going to be equal to that exponent. So since a to the x equals a to the x, and the example would be the log base 2 of 2 to the 7th is equal to 7. Okay, and then a to the log base a of x is equal to x. So since log base a of x equals log base a of x, this works. So this is really an exponential form, and we're changing it to logarithmic form. So even though there's a log, the log is in the exponent, so it's really an exponential, and we're changing it to log form. So an example would be 2 to the log base 2 of x equals x. If log base a of x equals log base a of y, then x equals y. So now what we're going to do is use those properties to kind of simplify these log problems. So if we have log 6x plus 5 to the log base 5 of x squared minus log 12x. So first thing I'm going to do, I'm going to keep this log 6x. I know from my rules that 5 to the log base 5 of x squared is just going to be x squared. So I'm going to rewrite this middle term as x squared, and then I'm going to keep this for right now, minus log 12x. So this x squared doesn't have a log attached to it, so I can't combine it with the other ones. So if I'm looking at just my log terms, I have subtraction, so that means I'm going to be dividing. So I'm going to rewrite this as log of 6x over 12x. Okay, so when you're combining things, you keep the log, and then you only need one of the logs, and then you take the numbers and you're dividing them since it's subtraction. And then we're going to keep this x squared on the outside since it's not attached to any log. And then I'm just going to simplify. So 6x over 12x, I can change this to be log of 1/2 plus x squared. Okay, in the second example, log 100 plus 6 to the log base 6 of 19 minus log 1. Well, log of 100, since we know the base is 10, if we figure out that 10 to what power is going to be 100, this just represents 2. The 6 to the log base 6 of 19 is just going to end up being 19 based off of our properties. And then log of 1, so again, the base is 10, so 10 to what power is 1? That's going to be 0. So then we're just going to combine those together and we get 21. Now we're going to use the laws of logs to expand